There is no specific requirement within the National Electrical Code (NEC) that mandates electrical conduit installations to be strictly parallel or perpendicular to the building's structure. This is a frequent misunderstanding encountered in the field. The code doesn't restrict the direction in which conduit can be run. It permits the routing of conduit in any direction provided that the installation adheres to specific requirements for support, securement, and protection against physical damage. Conduit needs to be adequately supported using approved methods and hardware at intervals specified in the NEC tables such as Table 344.30 for rigid metal conduit, Table 344.30b2 for electrical metallic tubing, and similar tables for other conduit types. The spacing between supports depends on the conduit size, the type of conduit, and whether it contains conductors. Shorter intervals are required for smaller conduit sizes and longer intervals are permitted for larger sizes. The code permits some flexibility in support spacing where structural members provide adequate support. Proper securement involves using appropriate straps, clamps, or hangers designed for the specific type of conduit. These fasteners must be installed correctly and tightened to ensure that the conduit remains securely in place. The NEC mandates the use of approved methods for securing conduit to structural elements such as walls, ceilings, and floors. The selection of fasteners must consider the material of the conduit, the type of surface to which it is being attached, and the expected loads. Conduit installations must be protected from physical damage, especially in areas where they are exposed to impact, abrasion, or other hazards. The NEC specifies different methods for protecting conduit in various locations. One method is to encase the conduit in concrete or other protective materials. Another option is to install the conduit in a location where it is less likely to be damaged, such as above a suspended ceiling or behind a wall. In areas where conduit is exposed to physical damage, it may be necessary to use rigid metal conduit or other heavy-duty materials. It's essential to consult the specific requirements of the NEC for your jurisdiction and the type of installation you are performing. Local amendments or interpretations may exist. The electrical inspector is the final authority for code compliance. Always consult with the local electrical inspector to ensure that your installation meets all applicable requirements. If the conduit will be installed in an area subject to physical damage, then Article 300.4 addresses this topic. If you are routing through or near framing members, you must maintain a certain distance from the edge to prevent screws or nails from damaging the conduit. You might need to install a metal plate to protect the conduit. The specific distances are outlined in 300.4d. When installing raceways exposed or concealed, you must use straps, screws, or bolts to secure them. This should be done within 3 feet from boxes, conduit bodies, or other raceway terminations. You also need to support the raceway every 10 feet unless otherwise specified. Specific requirements exist depending on the type of raceway used. For rigid metal conduit, RMC, and intermediate metal conduit, IMC, you should follow the guidelines in NEC section 344.30 and 342.30 respectively. Electrical metallic tubing end should be supported according to NEC section 358.30. Flexible metal conduit, FMC, has specific support requirements outlined in NEC section 348.30. Liquid-tight flexible metal conduit, LFMC, and liquid-tight flexible non-metallic conduit, LFNC, also have their own support rules in NEC sections 350.30 and 356.30 respectively. Proper support ensures the longevity and safety of the electrical system. Always consult the NEC for the latest requirements and local amendments. Always remember to check with your local authority having jurisdiction, ODG, for any local amendments or interpretations of the NEC. They have the final say on whether or not your installation is compliant. The NEC doesn't explicitly forbid running conduit at angles, but it emphasizes that the installation must be neat and workmanlike. The NEC defines workmanlike installation in section 110.12, which generally means that the installation should be performed in a skilled and professional manner, free from defects, and with attention to detail. When running conduit at angles, it's important to maintain a consistent and organized appearance. Avoid sharp bends, unnecessary crossings, and haphazard routing. Use appropriate fittings and connectors to ensure secure and reliable connections. Consider the overall layout and design of the installation and strive to create a clean and professional look. Running conduit in a straight line parallel or perpendicular to the structure is generally considered to be more aesthetically pleasing. It can also make it easier to install and maintain the system. The primary concern should always be the safety and functionality of the electrical system. Make sure that the installation complies with all applicable codes and standards. Proper support, securement, and protection from physical damage are essential for ensuring the long-term reliability and safety of the installation. Always prioritize safety and quality over aesthetics. If you have any doubts or questions, consult with a qualified electrical contractor or inspector. They can provide guidance and ensure that the installation meets all applicable requirements. Running conduit at an angle, such as the crow flies, is permissible as long as it adheres to all other applicable NEC requirements. This includes proper support, protection from physical damage, and compliance with any local codes or ordinances. The term "as the crow flies" generally refers to the shortest distance between 2 points, which may not always be a straight line due to obstacles or other factors. When applying this concept to conduit installations, it means running the conduit directly from one point to another, regardless of whether it is parallel or perpendicular to the building structure. While the NEC does not explicitly prohibit this type of installation, it's important to consider the potential challenges and implications. Firstly, running conduit as the crow flies may require more bends and fittings, which can increase the cost and complexity of the installation. Each bend introduces additional resistance, which can affect the performance of the electrical system. Secondly, it may be more difficult to support and secure conduit that is run at an angle. Traditional support methods may not be suitable, and custom solutions may be required. Thirdly, it may be more challenging to protect conduit from physical damage when it is not run along a straight line. Exposed sections of conduit may be more vulnerable to impact or abrasion. Despite these challenges, it's still possible to run conduit as the crow flies while meeting all applicable NEC requirements. The key is to carefully plan and design the installation, select appropriate materials and methods, and ensure that all work is performed in a workmanlike manner. When deciding whether to run conduit at an angle, it's important to weigh the potential benefits against the potential drawbacks. In some cases, it may be the most efficient and cost-effective solution. In other cases, it may be more practical to run the conduit along a straight line. The specific requirements for conduit installation can vary depending on the type of conduit, the location of the installation, and the local codes and ordinances. It's always a good idea to consult with a qualified electrical contractor or inspector before beginning any electrical work. They can help you determine the best approach for your specific situation and ensure that the installation meets all applicable requirements. The NEC provides detailed guidelines for the installation of various types of conduit, including rigid metal conduit, RMC, intermediate metal conduit, IMC, electrical metallic tubing, EMT, and flexible metal conduit, FMC. These guidelines cover topics such as support, securement, bending, and grounding. The NEC also includes specific requirements for conduit installations in hazardous locations, such as areas where flammable gases or vapors may be present. These requirements are designed to prevent explosions and other hazards. When installing conduit in a hazardous location, it's important to use approved materials and methods and to follow all applicable codes and standards. Failure to do so could result in serious injury or death. The NEC is updated on a regular basis to reflect changes in technology and industry best practices. It's important to stay up to date on the latest requirements and to consult with a qualified electrical contractor or inspector if you have any questions. The NEC is not intended to be a substitute for professional training and experience. It's important to have a thorough understanding of electrical principles and practices before attempting any electrical work. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. The code does not dictate aesthetics, such as requiring runs to be perfectly parallel or perpendicular. However, compliance with 110.12 requires a neat and workmanlike manner. This provision gives the inspector the latitude to require correction of runs that, while code compliant from a safety aspect, appear sloppy or unprofessional. The NEC is a comprehensive set of standards designed to ensure the safe and reliable installation of electrical systems. It's an essential resource for electrical contractors, inspectors, and other professionals who work with electricity. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is developed by the National Fire Protection Association, NFPA, a non-profit organization dedicated to reducing death, injury, and property loss due to fire, electrical, and related hazards. The NFPA brings together experts from various fields to develop and update the NEC on a regular basis. The NEC is adopted by many jurisdictions throughout the United States and is often used as a model code for electrical safety standards in other countries. The NEC is a valuable tool for ensuring the safety and reliability of electrical systems. The general rule is found in 300.11, which states that raceways, cable assemblers, boxes, cabinets, and fittings shall be securely fastened in place. Support wires that are independent of the raceway, cable, or boxes are not permitted as the sole support. The NEC allows for some flexibility in how conduit is run, but it always comes back to ensuring safety and a professional installation. Remember, the goal is to create an electrical system that is both safe and reliable. Always consult with a qualified electrician if you have any questions or concerns about conduit installation. The electrician will be able to assess your specific situation and provide guidance on the best way to proceed. By following the NEC and working with a qualified electrician, you can ensure that your electrical system is installed safely and correctly. Also, always ensure you bond your metallic conduits per NEC 250.92 so you don't have a difference in potential and energize the conduit in the event of a fault. Bonding is critical. Grounding the conduit provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent protective device, such as a circuit breaker or fuse. This helps to prevent electrical shock and fire hazards. The NEC specifies the methods and materials that must be used for grounding electrical systems. These requirements vary depending on the type of system and the location of the installation. It's important to follow all applicable NEC requirements to ensure that the electrical system is properly grounded.